Hello, everyone. Mr. Minnick's my name. Math is my game. And today I'm a little under the weather, so I'm going to try to record this. Hopefully, you can understand what I'm saying, and it'll be all good. So, the topic today is simplifying radicals. In a second, I'll show you what the title of this probably could have been or should have been to make more sense. So, the kind of thing we're going to be seeing is this. Example one, simplify. The directions always say simplify or write in simplest radical form. So simplify something like the square root of 44. Okay. So what a lot of you will be tempted to do is to use some kind of calculating device and take the square root of 44. And this is going to give us a decimal of 6 point something. In this case, 6.63. Okay. Well, I don't know if you remember or not, but in Algebra 2, I said decimals don't exist ever again, unless maybe in the context of a story problem. Okay, so the point is that 6.63, that's an approximate answer. If we square 6.63, if we square it, we don't get 44. Okay, so that's why 6.6, and you might say, well, let's square 6.6332. 49581. Let's square that. And that gets us back to 44. But you're probably not going to write out that many decimal places, okay? So the point is we don't want decimals. We want some other kind of answer. Now, if we go to the TI Inspire CAS, your Inspires that you use, the yellow ones that I have in the class, they won't do this, okay? But this Inspire CAS certainly will. So if we look, we see that the square root of 44 is 2 rad 11, 2 times the square root of 11. And that's the kind of answer that we will be looking for here, okay? If you remember anything from geometry, you did this back then. In Algebra 1, you probably did stuff with that in Algebra 1. And some of you were good at this, and some of you had no idea what you were doing. And you just hoped and wished you got the right answer, and you probably got things backwards. Your teacher probably said, well, you could have simplified it further. So today what we're going to do is talk about simplifying radicals, okay? First things first, this symbol, of course, is a radical sign. Has nothing to do with politics. This is totally math related, okay? If I could bring to your attention with my magic marker, right there, nobody ever pays attention to that because there's nothing there. Well, there's supposed to be something there. Okay, there is supposed to be something there because we're dealing with a square root. Keep in mind, a radical sign is nothing more than a square root symbol. Okay, so the radical sign is the same thing as a square root symbol. Because it's a square root, the number that's supposed to be in there, and it is supposed to be a number, it's supposed to be the number 2, okay? Interesting story. It is true that that number is called the index. That number is called the index. So if we're taking a square root, we don't need to write the index of 2, but be aware that it is there. In an upcoming chapter, we're going to be taking cubed roots and fourth roots and fifth roots, and we will be writing indices there, okay? One other thing to note, the number under the square root sign has a name, and it's called the radicand, okay? So you'll hear me use these words, the index, the radicand, okay? So in the case of 44, when we have the square root of 44, 44, of course, 44 is the radicand, okay? So what does it mean for a number to be in simplest radical form? What does it mean for a number to be in simplest radical form? Well, it means a couple things. Simplest radical form. One thing it means, and we probably won't get into this much this week, but it means there's no radicals in the denominator. There's no radicals in the denominator. There are no radicals in the denominator. In other words, we're not allowed to have something like 3 over the square root of 2. Okay? We're just not allowed to have that. Now, if you go on to take trigonometry, maybe even later on when we study the unit circle, you'll see that 3 over radical 2 would really be 3 radical 2 over 2. But for now, just realize there's not allowed to be any radicals in the denominator. Okay. So if we have a fraction, we're not allowed to have the square root signs in the bottom of the fraction. Okay. So another thing that it means for a number to be in simplest radical form is any and all like radicals are combined. Okay, like radicals are combined. So we're not going to do a whole lot of operations right now with like radicals, but if we had something like 3 rad 7 plus 4 rad 7, and I'll abbreviate radical with rad if you didn't notice that. What happens is this is similar to having 3x plus 4x. And of course, if we had 3x plus 4x, we know that that would equal 7x. Okay, so 3 radical 7 plus 4 radical 7 would actually be 7 radical 7. Okay, so like radicals operate, they act like, they work like variables, or like terms, I should say, like terms. Okay. The third and final thing, and perhaps the most important thing, and it's going to kind of lead into where we're going with this, the third thing about being in simplest radical form is this. The radicand, keep in mind that's a number under the square root, has no perfect square factors larger than the number 1. Of course, every number has a factor, it has 1 as a factor. Okay, but to be in simplest radical form, here's the big idea. The number under the square root, it's called the radicand. Okay, it doesn't have any factors that are perfect squares bigger than the number 1. I'll give you a minute to write that down. Again, so to be in simplest radical form, there's no radicals in the denominator. Like radicals are combined, and the radicand, the number under the square root, doesn't have any factors in it that are perfect squares bigger than the number 1. So if you haven't figured it out yet, I know I mentioned it last week, so maybe you remember from last week. When you simplify radicals, you're going to be finding factors of numbers. Okay. More specifically, you're going to be looking for perfect square factors. Okay, so if you don't remember your perfect squares, well, there's going to be that perfect squares test for my Algebra 2 classes here this week, probably tomorrow. So, of course, 1's a perfect square, 4, and then what, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so those are the first 10 perfect squares. Okay, so we're going to be looking to see if any of those numbers, more specifically anything bigger than 1, so if any of these are a factor of the radicand. All right? So it's important that you know what perfect squares are, that you can quickly recognize them, and quickly recognize them in the context of being factors of a number. Moving on to the next few perfect squares, of course, then we got 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Okay, those are the 20 that you're going to need to know. These are the 20 that you're going to need to know for the test that's coming up soon, probably tomorrow. Okay. So it's real important that you can recognize those numbers. So I wanted to go to this earlier because simplifying radicals, it really shouldn't be called simplifying radicals. It should be called that. You probably can't see that because a lot of you are sitting so far back. So let me kind of redistribute the wealth here, if the software will let me. There we go. So this is kind of another way that we could think of simplifying radicals. Simplifying radicals is really factoring out the square root of the largest perfect square factor. That's the process that goes on when you simplify a radical. Factoring out the square root of the largest perfect square factor. I've never ever referred to simplifying radicals in this way, but I think in the context of factoring, the fact that we've been factoring, the fact that we kind of know how to factor out a GCF, I think this is going to make a lot of sense, and it's really going to hit home with you. So again, it should be called factoring out the square root of the largest perfect square factor. So some people like an algorithm, a step-by-step, how do I simplify a radical? Well, the first thing you're going to do is this. You're going to find factors of the radicand. So when you simplify a radical, you're going to look at the radicand. Remember we said you just got to look at it sometimes. So the first thing you got to do is find factors of the radicand. Now, you don't just find any factors, any old factors. What you want to be sure to do is be sure to look for perfect square factors. Be sure to look for perfect square factors. So instead of finding every single factor, sometimes you might not need to find every single factor. Maybe you just want to see if 4 divides it. Maybe you just want to see if 16 divides it. Maybe you just want to see if 9 divides it. Okay? The point is you're looking for the biggest perfect square factor. Did I just, oh, I didn't say that. What we're really after is we want to find the largest perfect square factor. The largest perfect square factor. And I'm going to put pair there, okay? So we're looking for the largest perfect square factor pair. That's supposed to say pair, not pain. It might be a pain to find it, okay? But this is really the most effective way of simplifying a radical. Not only do we find factors of the radicand, not only do we look for perfect squares, but we're after the golden thing we're looking for here, the golden goose, the golden egg, whatever, is the pair of factors in which we have the largest perfect square. That's what we want. Now, I would be remiss to not show you the mathematics behind what happens. So I'm going to show you step 2, but we're really going to kind of skip over step 2. I hate to say that, but so in step 2, what we're going to do is we're going to rewrite the radicand. We're going to rewrite the radicand as the product of those factors, as the product of those factors. Okay. Step 2, we're going to rewrite the radicand as the product of those factors. That's weird the way you use those different colors, Mr. Minnick. I don't like it. Well, let's see. Let's see how it turns out. Rewrite the radicand as the product of those factors. I don't know if it's going to let me turn that writing into blue or not. I hope it does. I think I broke my computer. So we're going to rewrite the radicand as the product of those factors. Okay. Yeah, my computer's not cooperating right at the moment. That's okay. It's all good. Now, when we do this step, what we want to be sure of is this. You know, the commutative property of multiplication says it doesn't matter. It's not important what order we write them in. But in this case, it is. Let's write the perfect square. Let's write the perfect square factor first. first. Okay, it's real important here, writing the perfect square factor first. Okay, now I did say we're going to kind of skip over step 2, but it's important that you understand what steps 2 and 3 are. Okay, if you don't understand them, you're gonna mess up the final answer. I almost said product, but it's really not a product in this context. It's probably confusing, bad choice of words to say product. So anyway, the third step is to use the product property. Use the product property to split the radicand. To split the radicand into 2 radicals. Okay, so steps 2 and 3 are really the math, really the mathematics behind what we do when we simplify a radical. Okay, step 3 is use the product property to split the radicand into 2 radicals. Okay. So the product property is true for any non-negative, I should say, any non-negative real number. It says the square root of something times something is the square root of the first something times the square root of the second something. Okay, that's what the product property says, and this is true where A and B are greater than or equal to 0, and they're real numbers. Okay, so we can't use this particular property if we're dealing with negatives, but it is true for positive real numbers. Okay. Now I know you're anxious to get into an example, and we're almost done. So keep in mind steps 2 and 3, rewriting and splitting the radicand up. Those steps are really going to kind of be combined. Okay. And now I've really done it. Now my computer says, no, we're not going to do anything. So I'm hoping that this will catch back up to where we're at. Okay, got the calculator back functional. So the fourth and final step then, is that simplify. That should say simplify. So step 4, simplify. And I'm just going to leave it at that, simplify. What I mean by that is the radicand with the perfect square factor. So the radicand with the perfect square factor just becomes an integer, or a whole number if you want to think of it that way. That's why we're looking for perfect square factors. That's what ends up happening. The radicand with the perfect square factor is just going to become an integer. And so what's going to happen is there's going to be part of a radical left and an integer. Okay, and it's important that we get the order right. Sometimes some math software gets the order wrong, and they get it twisted. They write the integer after the radicand. That's not cool to do that. So let's just dive right into an example, okay? Example 2. Let's try to. If the computer wants to cooperate here. 19 minutes into this video, and my computer says, nope, I have a feeling it's not going to render the video. So we tried example 1, the square root of 44. So let's try to follow these steps. Let's see if we can put these steps to it. Step 1, find the factors of the radicand. So 1 in 44. Okay, 2 and 22. 4 and 11. And remember what we're looking for. We're looking for perfect squares. Now 1 and 11 are both perfect squares. But we're looking for perfect squares that are bigger than 1, and we're looking for the largest perfect square factor. So the deal is 4 and 11, that pair has the largest perfect square in it that we're going to find for that particular radicand. Okay? So moving on to step 2 then. Step 2 says let's rewrite the radicand. Let's rewrite the radicand as the product of those factors, 4 and 11. Step 3 says, okay, let's split that up into 2 radicals. It's going to be the square root of 4 times the square root of 11. And the last step says simplify the radicand with the perfect square factor. It's going to become an integer. So this rad 4 is going to become just 2, and a lot of people still want to have a radical with it. The square root of 4 is simply 2, okay? And then the square root of 11 remains behind, and that's our answer. That's it, 2 radical 11, and we saw that with the calculator, okay? So hopefully this kind of gets you going in the right direction. So let's try this with a couple other ones, because I love examples. Examples are good. Let's try to simplify the square root of 200, okay? So you might think to yourself, I know that 25 times 8 is 200. Well, that's right. So you might say, okay, so it's going to be the square root of 25 times 8. So it's going to be the square root of 25 times the square root of 8. And the square root of 25 is just 5. And the square root of 8, oh, wait a minute. That's not simplified. That's not in simplest radical form. And you might say, well, why not? Well, let's back that thing up a minute. The radicand has no perfect square factors larger than 1. So if we think about 8 for a minute, 8 is really 1 times 8 and 2 times 4. And 4 is a perfect square. So what that would be is 5 times the square root of 4 times 2. Remember, write the perfect square factor first. So that would be 5 times the square root of 4 times the square root of 2. And don't forget that the square root of 4 is just 2, so that's going to be 5 times 2 times the square root of 2. And I hope we know that 5 times 2 is 10. So the answer should be 10 times the square root of 2. So I don't know about you, but let's look at how many steps there were here. Okay, there's 1, 2, 3, 4, 5, 6 steps, okay? Because we thought that we knew, maybe actually 7, okay? Took us 7 steps to do that one because we thought we had the right factors. Well, if you do a little bit of planning on the front end of this, it's going to be way easier on the back end of this. Check this out. Remember when we find the factors, we're looking for the factors that have the biggest perfect square in it, okay? Of course, 8 and 25 is a perfect square, okay? But that's not the biggest perfect square. Now 4 and 50 go into 200, and 4 is a perfect square, but 4 is not the biggest perfect square factor of 200, okay? 2 and 100, I hope and I pray that you recognize that 100 is the biggest perfect square factor of 200, okay? So winner, winner, chicken dinner, 2 and 100, that's our winning combination here, okay? 2 and 100. And a lot of people, they don't do that. And some of your math teachers in the past might not have taught you to look for the biggest perfect square factor, okay? And that's why you hated these. That's why you sucked at them, because you didn't do the procedure that was most effective. So this is going to be the square root of 100 times 2, which is the square root of 100 times the square root of 2, which is the square root of 100 is just 10, and the square root of 2 is just the square root of 2. And that's your answer, 10 times the square root of 2. So if we think about this, once we find the factors, we simply factor out the square root of the perfect square. A 10 gets factored out of the square root of 200, okay? Keep in mind that something else is left under the radical. So let's try another one. So let's try the square root of 300, okay? So at least when you're doing these, at least say, okay, so 1 in 300, 2 in 150, 3 in 100. At least do this much work off to the side, right? So remember, a title that would have been good is factor out the square root of the largest perfect square factor. So the largest perfect square factor is 100. Factor out 100's square root, which is 10. And then what's left? Well, you still have a radical, and what's left under there is that other factor. And that's it. We get 10 radical 3. Well, that's easy. Let's try the square root of 500. 1 in 100. No, 1 in 500, I mean. 2 in 250. 3 doesn't go into it. 4 does, 125 times. 5 goes into it 100 times. Hey, there's our winners. So the square root of 500, remember, factor out the perfect square's square root. So the square root of 100 is 10. We still have a radical, and what stays under the radical is the other factor, so it's 10 radical 5. Okay. So I know what you're thinking. You're probably thinking, well, then the square root of 400 would just be 10 rad 4. Well, it's not. Okay, it's not. Because if you know your perfect squares like you do, like you should, you'd realize that 400 is a perfect square. And so when we simplify the square root of 400, that's really just 20. Okay. So be careful on those. Sometimes you're going to be simplifying a perfect square. Let's do one more example. Square root of 72. Okay. Now some people want to go ahead and find all the factors. One of my students a few years back, they said, you know, Mr. Minnick, if I just start looking over here, I'm probably going to find the biggest perfect square factor really fast. Really fast. What do you mean? Well, 72's got a lot of factors. 2 and, let's try that again. So 72's got a whole bunch of factors, if you remember right from before. 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. And a lot of those are perfect squares. For instance, 9's a perfect square. 4 is a perfect square. 36 is a perfect square. Well, which one's the biggest? Of course, it's 36. So when we simplify the square root of 72, it's going to be the square root of 36 times 2, square root of 36 times the square root of 2. So our final answer here is 6 radical 2. Okay. You might ask, is it important if I get these numbers in the right order? Yeah, that's important. Yeah, that's important. You have to have those in the right order. If you have those in the wrong order, it's wrong. Okay. The square root of the perfect square factor is factored out. Hopefully this makes sense. Let's look at one more. The square root of 42. A lot of people look at that and they think, you know, I'm asked to simplify it. It's got to simplify. Well, let's look. Find the factors. 1 and 42, 2 and 21, 3 and 14. 4 doesn't go into it. 5 doesn't go into it. 6 and 7 do. So we're looking at all these factors, and we're looking for ones that are perfect squares. And the only one that's a perfect square is the number 1. Well, wait a minute. A number is in simplest radical form if what? If the radicand has no perfect square factors larger than 1. So in the instance of the square root of 42, well, you can't simplify it. Your answer is just the square root of 42. Because 42 doesn't have any perfect square factors larger than 1. Okay. One final note about these. In the homework and the exercises, sometimes they like to put negative signs in them. So suppose you had something like the square root of 8 with a negative sign out front. Okay. The way I would recommend handling this is to kind of forget about the negative sign for a minute. Okay, forget about the negative sign. So 8, 1 and 8, 2 and 4. So the square root of 4 is going to be factored out. So a 2 is going to be factored out. and then the other factor is going to stay as the radicand, okay? And then think to yourself, well, that negative means it's going to be the opposite of that. So then kind of bring the negative along, okay? So negative, whoop, negative the square root of 8, negative the square root of 8. There you go. Okay, it's been real, it's been fun. Hopefully it's been educational. I'll see you. Have a great day. Good.